Hello everyone, we are Group 7 and we are reporting the instruments for electricity or circuit elements in electricity. Nikola Tesla once said, if your head could be turned into electricity, it would light up the whole world. First, we define what is electricity. Electricity is defined as the rate of flow of charges in a conductor. The charges move from one end of the terminal to the other end. It generally moves from a positive terminal to negative terminal. As the electrons are loosely held by the nucleus, they travel freely within the limits of the body. Ammeter. Ammeter is invented by Austrian electrical engineer named Friedrich Drexler in 1884. Ammeter is an instrument for measuring either direct or alternating electric current in amperes. An ammeter can measure a wide range of current values because a high values only a small portion of the current is directed through the meter mechanism. A shunt in parallel with the meter carries the major portion.
This is how to use an ammeter. These instructions work for any basic ammeter, but these are the ones we use in class. Notice the two ranges, similar to the voltmeter. One is the 0 to 5 amp range, the other one is the 0 to 1 amp range. Negative is labeled negative, and it's black. Positive, two possibilities for the positive. You can connect either to the side, like that, or if you screw in those little plastic nuts, you can connect to the top. Just make sure you get metal every time you clamp. Two different ranges are represented by the positive 5 amp range or the positive 1 amp range, with the two different connectors in the two different ranges.
Voltmeter. Voltmeter is discovered by a Danish physicist named Hans Christian Ørsted in 1820. Voltmeter is an instrument used for measuring electric potential difference between 2 points in an electric circuit. It is connected in parallel. It usually has a high resistance so that it takes negligible current from the circuit.
Here is how to use a voltmeter. The instructions work for any meter, but this is the one that we use here in class. The big fat V says voltmeter. Notice that there are two ranges, the upper range to 15, the lower range to 5, and the connector is down at the bottom. The black one is negative, and there are two positives, one for the 5 volt range at the bottom, one for the 15 volt range. That's the device. Some definitions are important. First, voltage is electric potential difference. Synonyms, and both of them are defined as the energy difference, or the energy change, or the energy loss, or the energy gain per coulomb between 2 points. And that is why we measure voltage this way. The voltmeter requires two leads. One is positive, one is negative. The negative always goes to the black, and there are two possibilities for the positive. One that has a maximum range of 15 volts, that's the one you generally start with. One that has the maximum range of 5 volts, which if it's below 5, you can move it down to that. There's two different ways to connect it to these, either through the top or on the side. Remembering that definition.
The shunt is used to measure electric current alternating per current. This is done by measuring the voltage of a closed resistor. The shunt is invented by an Australian electrical engineer named Friedrich Drexler. This shunt can be used in a meter to measure large currents, acts as a resistor. The known quantity of resistance is used to obtain an accurate reading.
Hello, today I will show you a homemade shunt for measuring DC current. So let's test it. And it's really easy to make it. This is just aluminum wire, thick, and measuring wires are connected just there and there. It 1 milliamp to there means 1 ampere. So you just take the wire and measure where you got 1 millivolt at 1 amp, and just I glue this blocks of wood to this, and there I put connectors like this, and there are just wires, and you connect those to multimeter, set on milliamps, and you're ready to go. Measure to about maybe 100 amps. So there I connected my multimeter, set to millivolts, and that wires are connected to there and there. It measures the voltage drop. So let me connect it. This is made for measuring high amperage. So I will test a regular 21 watt bulb, 12 volts. You see? It's drawing 1.5 ampere. It measured 1.5 amps, this bulb. And now let's put a bigger load. It's about 4 amps. This long piece. If it's shorter, it will pull more amps. Watch. 7 amps. Eight amps. Short circuit. 30 amps. Now let's test it accuracy. So there I connected my multimeter and set on 10 amps. So let's measure it. And it's 1.6 amps, and it's dropping. So it's pretty accurate. This measured about 1.5 amps. So it's pretty good for measuring large DC currents. So if you like this video, 10 thumbs up and subscribe.
Amperl invented the first clockmeter in 1948 and has continued to innovate and evolve. Clockmeters are used to measure the current flowing through a conductor. AC clockmeters are a current transformer and reading. With the help of the current transformer, the reading will be taken. There are two types of clockmeters: the AC clockmeters, which is used to measure the AC, and the DC clockmeters, which is used to measure the DC.
G'day guys, Wes from Unsealed. So, the last little thing we're going to do in the beginner's guide to 12 volt system, the tools at least, is the clamp meter. So, you may or may not have seen one of these. It's got a clamp on it. And the beautiful thing about this is that it lets you test amp draw, current draw on your system. Don't get me wrong, it works on AC as well, but we're just going to use it for DC.
but you don't need to break the circuit to do it. You can literally have a circuit powered up, put a clamp meter around the wire, and it'll tell you how many amps you're drawing. It's really good for a lot of things. So let's get into showing you how they work and what they do. And this is my personal favorite, guys. This is the clamp meter. Really simple to use, really cool little bit of kit. Now, as you probably have seen in the multimeter one, you can do similar things with a multimeter that you can do with this. This just makes life a little bit easier. So if we wanted to, just say we had lights connected up to this circuit, say we had a spotlight connected over here, which we don't. Pins are not connected to anything. But if they were, we could work out how many amps we're drawing through that light. Right, so with a normal multimeter, you have to put one terminal on here and the other one on the light up to a maximum of 10. And the problem with doing that is if we're drawing more than 10 amps, we can blow the multimeter up or the fuse in it. And then you've also got to break the circuit. Whereas this one, we could have the connection already done, right? So we're connected already here. You got your light over in the background there. And then all we've got to do is put the clamp meter around that wire. And it will then tell us how many amps we're drawing through that wire. So it goes through, all right, it won't work if you stick it on top, if you put it underneath, if you hold it around, it won't work. It has to be between the jaws, it has to be inside the jaws. Once it's there, it'll give you a really good reading of that. What you can also use these little things for, so obviously it will tell us volts. All right, you can use it as a normal multimeter. It will tell us how many volts we've got. Okay, obviously you've got your standard ports. You've got your COM, which is your common, so that's your earth. And you've got your positive, which will give you volts, temperature, ohms, and capacitance. All right, so we can go obviously to ohms with our ports, which are not connected, temperature, and then 40 amps DC, 400 amps DC. So if you're going to test something in a car, fingers crossed it's under 40 amps, unless it's like a proper big power cable, at which point you go to 400. All right, but for most of the stuff we're going to do, you're going to go there. Okay, and that will give you a really good indication of what we're doing. So simple as turning it on, 0 off the gauge, and around a wire. Can be negative, can be positive, doesn't matter. I always, for some reason, do negative. For some reason, my brain's telling me there's a really interesting piece of information as to why. I can't remember it, so it'll work on both, but I just have a habit of using the negative. All right, and that is our humble little clamp meter. They are a magic bit of kit.
Potentiometer is an instrument for determining potential difference or electromotive force by measuring the fraction of it that balances standard electromotive force. A potentiometer can provide a high-precision measurement. The carbon potentiometer we use today was developed by Thomas Edison in 1872.
Alright, so those who watched my first video, so now you made this LED glow. Alright, so cool, but what if you want to vary the voltage a little bit? Make it, glow brighter and less brighter. So it's really simple. All you need is 3 components and 2 things, a hookup wire, and that's it. And your standard 5-volt regulated power supply. So right here I have a 100k ohm potentiometer. These are really standard. As long as it's just any pot potentiometer will work. This is a 2k ohm potentiometer, and I have another 500k ohm pot around, and also a photoresistor. But moving on, we have the standard 220 ohm resistor that I used in my other video right here. And then right here we have that same red LED. You can use the same exact one that you used before, just don't burn it out. Yeah, so let's get started. So the first thing you want to do here is plug your potentiometer right here. You'll see that there's 3 prongs. So the prong in the middle, that's usually the input prong for like inputting voltage. So I'll just do that. I think you can. It doesn't really matter on this. And the next thing you want to do is use your 220 ohm resistor right here. You plug it into the middle prong. Well, I have them connected by wires to the plus 5 voltage. And then the next thing you do is just remember, so that's plus, so you're going to be hooking up the small or the shorter lead into the negative terminal. So let's do that. Great. So you might want to just double check your wiring. Everything seems to be working okay. All right, good. Now let's turn it on, and here we go. All right, so cool. So this is it. Turning the pot. There's the voltage. Since this is 100K, you're not gonna have very much variance. But if you have like a 1K or 2K, 5K, I don't know, it'll be a lot better than this. But also, a word of warning: make sure you have this 220 ohm resistor. So that basically means that the voltage won't dip below this voltage, because if it or won't go higher than this voltage. Going through the 220 ohm resistor won't like the resistance won't go any lower than 220 ohms. So because if you do that, if you don't have this, you might burn your LED out when you try to turn it up too much. So yeah, so turn it up, and that's the farthest it'll go with the 220 ohm resistor in series there. So yeah, that's about it, guys. Thanks for watching, and check out my next video.
Ohm meter can be defined as it is one kind of electronic device mainly used for calculating electrical resistance, and the unit for resistance is ohm. The world's first high resistance ohm meter was developed by Evershed and Vignoles in 1889.
Before using an ohm meter, turn it off so you can set it up safely. Then match the color of the leads to the color of the sockets. Plug them in and turn the ohm meter on. To zero the ohm meter, turn the dial to the left and lightly touch the probes together until the meter reads 0. Then you're ready to test an object's resistance. Simply touch the positive probe to one end of the object and the negative probe to the opposite end and read the meter.
Electrostatic voltmeter. An electrostatic voltmeter measures the voltage of any particular material surface without transferring its current charge. In other words, the instrument more precisely measures the static charge generated by a material's surface without contributing excess charge to the results in the process. The first electrostatic voltmeter was invented and produced by Lord Kelvin in 1880. Electrostatic voltmeters are typically used in the industrial sectors. They are used for a wide variety of applications specific to business in that industry. The uses might include measuring the surface voltage of industrial materials such as rubbers, plastics, and polymers.
On the table beside me, there is a stainless steel plate mounted with 3 different sizes of copper plate. Between copper plate and the stainless steel plate, there is an insulative layer protection. We use 5 pieces of alkaline battery to be connected in series and supply 45 volts constantly to the copper plate. Connect the TREC 520 grounding with the same grounding point of the copper plate. Then we measure the copper plate from big to small size accordingly. The largest size around 45 watt, the medium size around 45 watt, the smaller size around 45 watt. The measured voltage is almost same with the supply voltage on the copper plate. Next, we use field meter for the next experiment. The largest size around 45 watt, the medium size around 30 watt, the smaller size around 10 watt. Based on the above experiment, we can notice that the distance measurement of the TREC 520 is adjustable and able to measure on different sizes. It also comes with high accuracy and fast response time. On the next experiment, we will place an ionizer on the testing area to stimulate real-time surrounding in the production area. The measured voltage for the TREC 520 is very stable and still around 45 volt even in the presence of the ionizer. However, when we're using the field meter, the measured voltage value is highly fluctuate and unable to capture the actual value. Based on this experiment, it shows that TREC 520 voltmeter can perform measurement under ionization area and not affected by surround electric.
Digital voltmeter. Digital voltmeter are resistance that may indicate an open circuit or ground. The first digital voltmeter was invented and produced by Andrew K. of Nonlinear System in 1954. Digital voltmeter is used to know the actual voltage of different components. DPM is widely used to check if there is power in the circuit, such as main outlet.
A wattmeter is a very useful tool used by electricians and anyone on electricity business to measure the amount of electricity being used. A wattmeter, it's an instrument which gives a visual indication of the amount of electrical energy being supplied to a circuit. There are two commonly used types of wattmeter. The analog, these are the electrodynamic instruments and consist of 3 internal coils, 2 static current coils, and movable potential coil, which has an indicator needle attached to it. Wattmeters are typically rated for a set voltage range but may include features such as coil tops, which allow for multiple voltages.
Mr. Jackson said that all we had to do was plug this into an outlet and then plug something else into it to measure how many watts it uses.
Do you have a phone charger?
Oh yeah, good idea. Do you know what this number means?
Well, it helps if we know what a wattmeter is measuring. A watt is the amount of energy expended over a period of time. In this case, we'll be measuring an hour of energy.
So that's what this number is.
Actually, this meter first measures the voltage of the outlet itself. That's how much potential energy the line is capable of producing.
But that's not the energy it's producing now.
Right. We need to set the meter to read kWh, or kilowatt hour consumption.
And a kilowatt is 1,000 watts.
You got it! So this setting will tell us how many kilowatts an electrical device expends over an hour of time.
So that reading is the kilowatt hour consumption of my phone since you plugged it in.
Yep, now if I push the button again, the meter now tells us how many hours have passed since we plugged in your phone.
Why would you want to know that?
Because if you divide the rate of kWh consumption of a device by the number of hours it's been plugged in, you get the rate of the device's consumption.
Makes sense. Just divide the first number by the second number, and you can see how quickly my phone drains energy.
Exactly.
Cool, man, that's really useful.
Yeah, so we should probably write our readings down.
Yep. There's room for them right here in the energy investigation packet.
Nice.
Next, we should measure how much electricity the school's furnace uses.
Or the refrigerator in the school kitchen.
Or the entire computer lab.
Right. Calculating the energy costs of equipment in the school can help us figure out which ones are draining too much electricity.
I see. Then we can think about replacing those devices with more energy efficient ones. You know, there's a column right here for Energy Star equipment. Are they supposed to be good?
Yeah, I heard these products save energy and are good quality, but even if that's not the case, we can still test their energy savings with the watt meter. We could even test which appliances have a phantom load.
Like a ghost?
Kind of like an electrical ghost. A phantom load is the electrical power used by some devices when they are turned off but still plugged in. Some electronics don't have a phantom load, but others eat up a lot of power while they're turned off.
Oh, and once we figure out which ones have a phantom load, we should just unplug those electronics when we're not using them.
Right, we can even test it now. See, even though your phone charger isn't charging anything right now, it's still eating up a lot of electricity just by staying plugged in.
Man, I see your point. You know, that's a really great tool to help us avoid wasting energy.
That's the idea. You can even use it to figure out what times of the day the building is using the most electricity and when it's using the least amount.
Sweet. Let's go down to the kitchen and get some readings. It's pizza for lunch today, and I want to see how much electricity the oven takes to make my favorite food.
Multimeter. A multimeter, also known as a volt-ohmmeter, is a handy tool that you use to measure electricity. Just like you would use a ruler to measure distance, a stopwatch to measure time, or a scale to measure a weight. Multimeter come in analog and digital version and are useful for everything from simple tests, like measuring battery voltage to detecting faults and complex diagnostics.
Hello Hooktubers, today I'm gonna show you how to use digital multimeter. Basic stuff. Let's begin.
When you decide to buy a digital multimeter, you must look for multimeter which can measure voltage, resistance, continuity and current. If you find one that measures capacitance and temperature as well, feel free to buy it. My digital multimeter is Fluke 17B and it's best multimeter that money can buy. It have automatic ranging functionality for many measuring fields, so we avoid wasting time with manual ranging. If you don't know which multimeter to buy, just get this one, Fluke 17B. It will do everything you need and you won't buy new one anytime soon. You can find link in description for this Fluke digital multimeter. Okay, now you have a multimeter, and how do you use it? Let's start with measuring AC voltages, but first check the cables. Make sure the black lead is in the jack labeled COM or COMON, and you will never need to take it out, because the black lead always goes to COMON. The red probe is something you need to pay attention to. If you plug into the wrong jack, you will blow a fuse in your multimeter, but this digital multimeter can protect itself on all stages. That's why it's the best multimeter money can buy. We're gonna measure AC voltage right now, so I'm plugging the red probe into the jack labeled volts and ohms, not amps. Set the dial to measure AC voltage. Here I am measuring AC voltage in my outlet, it's 220 volts. Now we're gonna measure DC voltages, so set the dial to DC voltage and once again make sure that the red probe is in jack labeled voltage. Touch the red probe to positive terminal of device and black probe on negative terminal and you should get a voltage reading. If you get wires backwards, that is okay, you will get negative reading on your multimeter, and this is good way to figure out polarity of measured battery. Measuring resistance is easy, just set the dial to resistance settings. Measuring continuity means checking is there good connection between any 2 points in the circuit or wire, and whenever there is almost zero resistance between 2 points, the multimeter will beep. Final setting is to set the dial to measure current, and for almost all multimeter there is separate jack for measuring current. This multimeter has 2 amp jacks, one for currents up to 10 amps and one for currents up to 400 milliamps. I always place the jack to amps. If I need more accuracy, I switch the jack to milliamps. In order to see how much current is flowing through some device, you have to cut the wire and set the multimeter in series with the flow and read how much amps is pulling the device. Hey, hit that thumb button with your mouse, it's below the video, and be honest when you last time click like. I know that the good videos should get likes, and I can say that this video is pretty good one. These are basic stuff you need to know about digital multimeter. Thanks for watching, subscribe and visit my channel page American Hacker. I have over 300 video projects.
Moving iron ammeters are generally used to measure alternating voltages and currents, as opposed to the direct currents measured by the galvanometer. In moving iron ammeters, the movable system consists of one or more pieces of specially shaped soft iron, which are so pivoted as to be acted upon by the magnetic field produced by the current in the coil. Now, one thing to note is that the measurements in the moving iron ammeter is nonlinear, meaning that as the analog stick moves up, the spaces between each measurement is not consistent. So, the next slide we see here a video on how to use moving iron ammeter as well as its diagram.
Measuring direct current and alternating current with moving iron meter. A moving iron meter is a device that makes use of the magnetic effect of an electric current. The following diagram shows the basic structure of moving iron meter. The moving iron meter consists of a coil inside, which contains 2 soft iron circular bars. The larger bar is fixed. The smaller bar is attached to an axle pivoted on jeweled bearings. When a current is flown through the coil, both the bars are magnetized with like poles adjacent to each other. Repulsion takes place, causing the smaller bar to rotate until it is stopped by the control couple, provided by the hairsprings. The rotation of the smaller bar causes the pointer attached to the axle to move over a scale. The larger the current, the greater the repulsion and subsequent movement of the pointer. The scale of moving iron meter is non-linear, that is, the scale is not evenly divided. This is because the force of repulsion between the irons is not directly proportional to the current flowing through the coil. The advantage of the moving iron meter is that it can measure both direct current and alternating current. The disadvantage of a moving iron meter is that its scale is not linear. Thank you for taking time to watch this.
Zero center ammeters are used where the voltage needs to be monitored in two directions. They are used along with the battery. In this, the charging of the battery deflects the needle in one direction, while the discharging of the battery deflects the needle in the opposite direction. Now, zero center ammeters are generally used in aircrafts, as you can see here in the next video on its applications on an aircraft.
Center zero ammeter is a simple gauge which measures electrical current flowing into or out of the battery. It's very important for the pilot to understand this gauge, as it can indicate a potential problem in the aircraft's electrical system. On this diagram, the alternator is a device that generates electrical current. It's mechanically driven by the aircraft's engine, so it only works when the engine is on. The bus bar is the distribution centre of current to the aircraft's electrical systems. Let's have a look at a few center zero ammeter indications. With engine off and the battery switched on, the battery is the only source of electrical current. The ammeter needle swings far to the left of zero to indicate a discharge. In flight, however, when the engine is on, this could mean that the alternator has failed. Since the battery has a finite charge, it can only supply current for a limited time. The battery is used to drive the electric starter motor to start the aircraft's engine. This process demands a lot of energy, so the battery drains quickly. With the engine on now, the ammeter needle swings far to the right of zero to indicate that the battery is recharging, and the alternator is supplying current to the electrical systems. Once the battery is mostly charged, the ammeter needle moves slightly to the right of zero. This indication is for normal operation in flight, as it suggests that the alternator is supplying the necessary current to the electrical systems and some excess to the battery. When the aircraft's electrical systems demand more current, the battery contributes to the supply. Consequently, the ammeter needle moves slightly to the left of zero as the battery discharges. Again, since the battery has a finite charge, it will only supply the extra current for a limited time. To fix this problem, switch off unnecessary electrical equipment to reduce the load until the center zero ammeter indicates a charge.
The galvanometer was the first type of ammeter. It is used to detect and measure electric current. It is an analog electromechanical transducer which makes a rotary deflection response to electric current flowing through the coil. A galvanometer can read direct current flow. The magnetic field created as current flows through the coil acts on the spring, which will then move the needle indicator, pointing to the unit measure. Now, in the next slide we see here a video on how to use galvanometer.
Okay, today we are going to experimentally derive Lenz's law. So first things first, we have galvanometers here. For those teachers that are watching this, the galvanometers are in series. Why is that important? Because that way you can have the entire classroom seeing what you're doing without having to move the galvanometer back and forth. A galvanometer is actually just an ammeter that records microamps. So it's a very sensitive ammeter. If you'll notice here, we have red going into black, and then red going through the circuit back to black. What I want you to see, because some students were a little confused about this, if current goes into the red, it will come out the black. Following the circuit, it will then go into the red here and out the black here. So again, because the way that charges work, if they're going in, they must go out on the other side, otherwise the circuit wouldn't be working. So let's find out how the galvanometers actually work. I have here a 1.5 volt battery, just a basic Duracell. Why did I pick a Duracell versus anything else? Because it has that copper top and it's very easy to see. That's the positive. I guess I could use a marker there to show that. So this shows the direction of positive current flow. That right there is a 6.6 kilo ohm resistor. It's 6,600 ohms. Why? Because I have to get the current low enough so that it will read on the galvanometer and not hurt the galvanometer. So looking at the galvanometer, I'm going to connect the circuit, and if the positive current is flowing into the red, it reads positive. Okay, again, looking over here at the circuit, the positive current flow is going into the red side of the galvanometer, and that's why it reads again positive. Now let's switch the battery around so that the positive current flow is flowing into the negative. So watching the galvanometer, it reads negative. So we now have an indicator. All this circuit is showing us, is proving to us what the galvanometer tells us. If positive current flow flows into the red, it reads positive. If positive current flow flows into the black, it reads negative. So up here on the board,